Here we're going to evaluate composite functions algebraically. So we're not going to have any numerical values we're putting in. We're actually going to put an x into g. And when we put an x into g, we get g of x. And then we're going to take that g of x and we're going to put it into f. Well, g of x, in this example, g of x is just 3x plus 1. So in place of g of x, I'm going to put 3x plus 1. So I'm really just looking for f of 3x plus 1. Now I'm going to go to the f function, which is x squared. And everywhere I see an x, I'm going to put parentheses. And then I'm going to put 3x plus 1 in its place. 3x plus 1 squared is the same thing as 3x plus 1 times 3x plus 1, which FOILed out is 9x squared plus 6x plus 1. Doesn't like me writing a box there. So here we'll try g of f of x. So this time, instead of putting g of x into f of x, we're now putting f of x into g of x. So f of x is x squared. So I'm going to have g of x squared. So I'm going to go to the x function, I'm going to go to the g function. I'm going to go to the g function, and everywhere I see an x, I'm going to put x squared in its place. So instead of 3x plus 1, I have 3 times x squared plus 1. And 3 times x squared is 3x squared. And then I add 1, and that is what g of f of x is equal to. And those are examples of composite functions. So that's putting a function in to another function. Okay, I'm going to give you a try. So I'm going to give you a try. Go ahead and press pause. So you're going to write that problem down and work it out. And when you're ready to reveal the answer, go ahead and press play. So we have an answer of negative 2x squared minus 4x minus 1. Negative 2x squared minus 4x minus 1. Now we're going to have another try. So here's another try. This time compute g of f of x and see what you get for that one. So go ahead and press pause, and when you're ready to see the answer, hit play. So here we have the answer, negative 2x squared plus 2. So hopefully you're feeling pretty good about these. We're going to go through and we're just going to try a couple of more numerical examples. So here we go. We have a numerical example. We want to find f of g of negative 2, given f of x is equal to 3x squared, and g of x is equal to 2x minus 5. So I'm going to rewrite this, f of g of negative 2, and I'm going to show you two different ways. I'm going to first go off to the side and say g of negative 2, and then I'm going to compute that, 2 times negative 2 minus 5, because g of x is equal to 2x minus 5. So that's going to give us negative 4 minus 5, which is negative 9. And then I'm going to have f of negative 9, and f of x is equal to 3x squared. So f of negative 9 is going to be 3 times negative 9 squared. Negative 9 squared is 81, and 3 times 81 is 243. So we get an answer of 243. The answer of 243. Another way that you can do this is you can say I'm going to put negative 2 into g, and then I'm going to get a negative 9 out, and then I'm going to take that negative 9 and put it into f, and then we get 243. So our answer is 243. No matter which way you like to do it, whether you like the notation with the open circle on the left or you like the bracket notation on the right, either one will get you the same answer as the other, which is 243. Okay, here's one for you to try. When you're ready to reveal your answer, go ahead and press play. So here we have an answer of 19. This gives us an answer of 19. When we put a -5 in for F, we get -19 out. And when we put -19 into G, the absolute value of -19 is +19. And that's how we get 19. And that concludes our lesson on composite functions.